Caching, it is a technique that you can never skip if you want to create robust and a resilient API. And in this video, I'm going to take you through how to implement this caching in your web API. You're welcome. As you know already, my name is Frederick and I'm happy to meet you today. In .NET, caching is a critical technique to improve the performance and scalability of application by temporarily storing data that is expensive to retrieve or compute. Data in your API or access points in your API that are often or frequently accessed, you can cache them to reduce the load from the server. And in that, there are several caching mechanisms available in .NET. There are a lot. We have the output cache, we have in-memory cache, and we have system.runtime.caching. Now, these three types of caching, we're using them as an in-memory cache. Basically, there are two types of caching, that is a distributed, and now we have the in-memory caching. Now, under the in-memory caching, the following that I mentioned are the types that we can use, or the technique that we can use to cache. So in this video, we're going to have a look on how to implement the output caching and also how to implement the distributed caching. So simply to explain this for you to understand it in just like one line, what I can say here is when we talk about in-memory caching, it is where data is stored in the web server's memory, making it very fast to retrieve. Okay, and I want to talk about the distributed caching. That is where you have a separate server which holds the cache for all requests or all servers go to that server, and now check if there's any cache data in there, then return to the user. If not, then process a new request, cache it, and I'll send it back to the user. I believe this is the most simplest explanation you've ever seen, isn't it? That's great. All right, so we are going to have a look on first how to implement the in-memory cache. You know that the in-memory cache, this data has been kept in the web server's memory, and that's why we say in-memory. When the server closes down, the data is ripped off. But when you take a look at the distributed cache, this cache is stored on a different server. So even when the web server is off, the cache still maintains. Okay, and let's see how to implement the in-memory cache. So I have a project created already, and that is a demo resilient and a robust API solution. I have made a couple of videos in here how to implement all the poly strategies. So I have made that as well available in the video description, so you can check it out and now look at the ways that you can improve your API communication by implementing all these strategies as well, making it robust and resilient. All right, so I have a simple solution created and I have two projects added in here. That's an API 1, API 2. We are assuming that API 2 is a service that you're calling externally. Okay, so this is not part of our API. We are making a call to that. Although it is here, but assume. Yes, assume it. All right, so this is what you're going to do. Now, I did not do anything differently. It is a normal default stuff that we have in here. When you take a look with the API 2, that is our service, you can see that we have a controller created, and that is a different thing. It's a normal thing that we're doing. You know, here we are having this endpoint here that is getting you the weather forecast list. Okay, so this is the rate limiting. We've done that already. So if you don't know that, you can check this video description for that video. Okay, when I'm done with this too, I'm going to combine the videos again together as one, so you can watch everything for you to create a resilient and a robust API from start to finish, and you're going to learn a lot in that video. Okay, so for now, we are not implementing any limit, so let's clear that. So if I run this API 2, let's see the default stuff that you and I, we know defaultly. Let me just run this, and now let's check it out. And our API is ready, as you can see from the screen. Now we have our API 2 opened, and I can see if I click on try this out, we have this weather forecast as a list of 1 up to 15. Yeah, that's the 15 list. Yeah, so that's a simple thing that we're doing. Now we're going to consume this as a service from our end API 1. Okay, so let's see from an API 1 to this what we have in there. So in the controller, this is what we are doing. From here, I can just close. These are the strategies that we spoke about in the previous video to make your API robust and resilient, and so that is it. We are not focusing on this today. What we are doing here is we're going to create another endpoint, and now in this you see that from here we are just making a call to this endpoint. Okay, So even with this is what I can do. I can just grab this and I'll create a new endpoint in here. Let me put this endpoint on top, and this is going to be HTTP GET as well. So let me make this as caching, and this is public async task. Let's use the interface of iAction results, and this is the name of cache. So within this is what we are doing. You're going to return, let's say okay. Then in that we have await. We have HTTP client instance injected, so get from JSON async. And now in here, maybe we can convert this to IEnumerable of weather forecast. Okay, so we are just returning this await. Then we have to specify the route in here. Okay, so it means we have to go in there and I'll copy only the link. So we grab this, then in here we can paste it on here, as you can see. Okay, so we are getting this from this weather forecast endpoint as a service, and that is this service. So when we run this, then we can have access to that 7001 as a port, and that is the same thing applies to this API too. Okay, now let's test this out. So from here, let's run both projects and now check it out. So here I'm going to configure startup project for the two and multiple startup. I'm going to start without debugging. Then let's run the two projects. You see it is ready now. So this is our API 1 and that is our API 2. So you're going to make a call to this service. You know this service is active. So let's say from caching, let's try to get this data from this API. And that's what we have in here. So we have all this data from this API 2. Let's say our service, and that's great. But I could say if I click on this, go to inspect element, and let's see now, I could say this is the first time of getting the data. So we assume or here is supposed to get cached so that anytime that I make another call, we don't populate it again. But look what's going to happen. So if I click on this, see it is still getting it in here. You can see it used what 59 milliseconds, okay, to get this from this API. So this is what we're going to do. Let's introduce a delay to this so we can use this to explain what this concept for you to understand it into details. So yeah, after let's say, all right. So before we do this, we have to then store this. Let's say this is var data is equal to this. Then we can now return. So let's remove this. We pass in this data in here, and then we can now close this peacefully. Okay, so we want to introduce delay to this. Okay, so maybe HTTP dot yes. Now let's introduce delay. So we're going to say await task dot delay. Let's introduce 3 seconds in this. Now let's run both projects again and check it out. So they are ready. Now right click on the API 1. Let's go to inspect. We go to the developer tool. Then we want to check this network tab. That's going to record the time that is going to be using for making a call to the service. So from the first initial call, let's say we are delaying for 3 seconds. So we're going to wait for 3 seconds before it gets the data from that service. So we took what 3 seconds and 52 milliseconds, right? So 3.52. Now when we make another call again, you can see it is still the same waiting for the same 3.52 seconds. Now you can see there is 3.06. So that 3 here, it is constant because we are delaying for 3 seconds. So let's see, this is going to give us a 3. Let's see, yes, so 306. Let that again, 306. So you can see that this is keeping on what delaying, but the same data, that's what we are making a query after calling this endpoint to retrieve. So can't we cache this so that it will reduce the number of request time or the processing time, and also it will serve or it will free the server or the database? Yes, we can. And that is what we're going to implement, the in-memory caching. Okay, so let's see how to implement it. Now, this in-memory caching here, it is coming from this default the Microsoft framework, and here we can have this output cache. It's also one way. We have the iMemory cache. You can use that interface, or you can use the output cache. So I'm going to introduce you to the output cache, and implementing this is very simple, very simple. Trust me, you're going to love this when you see that. So go to the program, your solution in there, and actually we want to implement it from the API 2 because that is our service. So any request that comes in here, you want to cache the processing of the result first, so that when a subsequent request comes in, we're going to release the cache data instead of going to the database and now populating it. Release the cache data. Okay, and now for this cache, it has time or expiration time. So when the time is due, it's going to clear that cache, and now anytime there's a new request comes in, it goes to the cache, and since there's no cache data in there, it goes to the database, populate it, and I return, and then cache it, and then give it back to the client. So at the time, you're going to have an update content in there. All right, let's see. From our service, from the API 2, you go to your program.cs file, and in there we need to register the cache service first. So in order to do that, you have to specify it builder.services. So .add output cache. And now after doing that, you have to implement or have to use this middleware pipeline, and that is an app dot. So use output cache. Okay, so now that we have this set and done, we have to add a service and add the middleware pipeline. Good. So now that we are done, what we're going to do here is we go to the API 2 as a service controller, and then here we have this. So we want to cache this. So in order to cache this, what are we doing? Let's see. So we're going to introduce the delay here. So I'm going to grab this from this here. Okay, so the right thing that's supposed to do here is to implement or introduce a delay on the service. Okay, so here, that is where the delay is supposed to happen. So let's see, and this is still going to work. Let's make it as async. This is task. And aside from doing this, so this is what we're doing. Like when we try this, it's going to work. It is the same. Let's see. Okay, so let's give it a try from the cache. We are delaying 3 seconds, so take note. Now the request is going in, and now let's see the response. It took what? So 3.59 seconds. Let's clear this, call it again, and it is still doing the same thing, going to take in the same 3 seconds point something. So let's wait and see. 3.11, the same thing, and now we are having the same result as well, 3.07. So 3 is a constant because that is what the amount time or delay time that we have specified. Now the reason why we have to delay here, it is a service. So let's assume the service takes much time to populate or compute the result. So in this case, it's going to delay. That's why we're introducing the delay in here, not in the client. Now this is a client. So when you delay here, let's say the service does not delay and this client delay. It doesn't make sense, okay? So you want the service to now get delayed. So when this get delayed, that is where it tells you that it's computing volume of data. And when we delay, we can also cache it so that when we get to start or when we get to try this, it won't delay. We're going to have it in a fast way of retrieving since it's using the cache instead of populating or computing it again for us. Good. So now that we have the service injected, we have the middleware pipeline being used. Now what we're going to do here is we're going to introduce the output cache in here. Now let's see. So output cache, implement this attribute, and now this attribute, there are a lot of parameters that you can specify. Have a look. So you can see here we have duration, we have no store, policy name, vary by header names, vary by query keys, and our route value names. What does each mean? For duration, you know what duration is going to happen. Now it's going to detect or tell the output cache the time that you want to keep this data for. When the time exceeds, it's going to clear the cache away. Now no store, when you set this to true, it means you are saying that this output cache shouldn't cache the content that you want to retrieve it from this specific endpoint. Policy name is maybe you have a specific configuration that you're going to do. You can do that in the program.cs file, and now you can use that policy in here. And also we have the tags. So the tags can be used to cache it based on the tag that you provide. Vary by header. When you have a special header that you want to cache, based on that, it's going to cache the content based on the header that you're going to specify. The same thing applies to the query. When you have a special query key that you want to cache it with, it's going to cache the content based on that key. And now when retrieving, and for the last one, when you have a special route value that you want to cache this with, then you can also do that. But what we are interested most here is the basic one, and that's why we need the no store. You're going to set this to false. I'm going to set the duration to maybe 30 seconds. So let's have duration set to 30 seconds, and also some no store, we set this to false because you want to cache this. Okay, now let's see. So this is going to be cached. The results that are going to have here are going to return from this, going to be cached for 30 seconds, and after that it's going to get cleared off. So any request or any client that make a request to this within that 30 seconds is going to retrieve the cache data, not the data from this. Okay, so maybe we can let's see. Let's run this and check it out. So let's click on this to run this up. So now that we have this caching implemented, let's see. So I'm going to make a first call. Now this first call is going to take 30 seconds, okay, because that's the delay time that we have specified. Now if I click on try this out for the first time, see it is pending and it's going to delay for 30 seconds. And I'll check it out. So it took 3.54 seconds. Now from the subsequent request within 30 seconds, let's see what happened. Click on this and I can see we have it. Now it took 104 milliseconds, and this is the result is from the I'm doing screen recording and etc. So that's the delay that you're having. But we see this is milliseconds and that is seconds. So from subsequent ones, you see 46, we have 48. All these are milliseconds until 30 minutes elapses or 30 seconds elapses. All subsequent or client requests are going to returned or served by the cache. So let's see. That's not 30 gets up. You can see that it clears the cache, and now you need to make another call again, and I have it in here. So you can see this cache is working. Good. This is automatically populated and managed, because here you cannot clear the cache manually. Because when you have a look at this, although we have specified this 30 seconds, so within that 30 seconds, in case maybe you want to clear the cache manually, how can you do this? Output cache does not have direct remove implementation, so I created a wrapper to wrap this, and in that I made it possible for you to delete it, to clear the cache and now delete it. So let's see how to also use that. Okay, it's a package that you need to install to manage this. So in order to use that, what we're going to do here is we have to install this package to the service. So I click on dependencies, and I'll go to manage NuGet packages, and in that we're going to type in for netcode. Yeah, so when we have the list here, the package that I have created, we are going to look up for this one. So that's a netcode-hub.packages.wrappers.output cache. So this is what you need to install. So install this package. The current version here is 1.0.1. So install this package in here. Then I just uploaded it yesterday or so. Yes, you can see Friday, May 31st. Yeah, so we have this package installed. Now let's reboot the project. Okay, so succeeded in building. So we have this already. Alright, so the next thing that we're going to do in here is, let's go back to our program. So instead of us having this service registered, no, I did it. So we're going to remove it. And also from the pipeline, we're going to also remove this one. So this is what you're going to do. We're going to be using the package service. So this is .add netcode-hub So output cache service. And now this is coming from this package. So netcode-hub.packages.wrappers.output cache. So you add the service, and now from the middleware pipeline, so app.use netcode-hub output cache. So you specify this here. Okay. So now that you have this, you can then go ahead and implement this by having the set, get, and remove method. Now this package has an interface that is the iNetcode-Hub output cache, and that interface contains the 3 methods that we can use to manage the cache. So let's go to our controller from here. Now instead of having this attribute specified on top, we're not going to do that. What we're going to be doing here is, when we have the list from this, we are going to store this in here. Okay. So data is equal to. So maybe when we make a call to this, first you want to check if the data exists. So we're going to say that maybe weather data. So this equal to, then we can have access to this await. But before that, let's inject this. So maybe we can use primary constructor in here, and I'll remove this. Okay, let's take off this iLogger since I'm not using that. So there's an iNetcode-Hub cache. Let's give it a name as netcode output cache. So now that we have this, we're going to say that await this dot, then we can have access to, you can see we have removed cache, get cache, and now we have set cache. So we have remove, and that's the set cache. So here we want to get this cache. And now this takes in the key and now the cancellation token. So what is the key in here? The key that I want to specify here, it is a, let's say this is weather data. And now let's specify a cancellation token. Token.none. So this is going to return string. So we need to deserialize this. Before that, we can say that if string here dot is null or empty, and here we are referring to this weather data. So either return here it is not equal to empty, then return, we need to, let's say this, okay, then let's use JSON serializer. So serializer. And now this is coming from, we can have access to system.test.json.serialize. Now here we're going to deserialize this. And I'm going to deserialize it as an enumerable of weather forecast. And that is all. Then here we specify this weather data in there. And you know, this we must have, we can decide to use the interface, or we can decide to use this action result. So action result. Then let's close this up. Yes. So we have this. So in case it is not now, we want to call this else. Then we want to delay and then call this. Now after we've called this, instead of us to return, no, we're not going to return. We're going to wait. Then let's cache it. So this is get cache, and now after we put in the cache is empty, we get the rare content from the database. Then here set cache. So let's set before we return. So after that we can return okay with the data that we have. But before we return the data, we have to set this cache. Now in order to set this cache, what we're going to do here is await. We're going to be using the same netcode-hub cache.set cache. Now this set cache, you need to specify the key. So what is the key? You make sure the key is the same as what you used to get. Then we have to specify the data itself. And now we're going to use the same JSON serializer.serialize this as a string. And now what is the content in here? That is the data. the data, that's the weather forecast list that we have it in here. After that, what is the time span that you want to hold it for? So let's use time span dot from seconds. You want to maintain the same seconds in here, so I'm going to pass in 30 seconds. Okay, then aside from that, we need to specify tags. So tags is, let's say this is null. Maybe tags are used to maybe group them in the cache, but for now let's maintain it as null. And aside from that, we need to specify cancellation token. So we have cancellation token dot none. Okay, so this is what we have in here. So let's arrange it well for you to get this. Now this is the cache key. So cache key is this one. Now the next one here, it is the data. So this is the data itself. And also we have that is a valid. This is supposed to be the tags. So tags, this will be null. Yes, then we have valid for. And we have the cancellation token. And that is a cancellation token that we need to specify in here. So let's see. Yes. Okay. So these are the properties, or these are the parameters that you need to specify. The key, the data, whereby you serialize it into a string. Then also we have the tags, we have the valid for the time or the time period, and the token. After that, we cache it, and now we go to return this. Okay. Now this set cache is going to return a tag. So yeah. In case there's any issue, it's going to throw it, because I surrounded that with try catch. So in case there's any issue, it's going to throw this, and you can also use try catch to retrieve or to get the data in case there's any issue. But with this, it's going to work, so don't worry. All right, so now that we have this, let's also have another method to clear the cache. So here we can have public, and this is just an async task. Let's implement the iAction results. This is clear cache. And now within this, we want to return, let's see, no content. Okay, but before we return no content, I think we have to clear the cache first. So return no content. But before we return no content, we have to make sure that we clear the cache. So Netcode-Hub cache dot clear or remove cache. Then what we're going to do here is specify the key. So that is the weather data. And also in case you have cancellation token, let's also specify the default one as none. And this is going to get the cache cleared. Yes. Alright, so now this is working. Let's see if this is going to work. Okay, we're going to try this. Now in the course of 30 seconds, whereby the cache still persists, we're going to clear the cache and now make a call again and check it out if the clear cache is working. If not, then we look into that again. But trust me, this is going to work 100% for you. Okay, so it is ready. Now I'm going to clear this. And also, once you're done, I'm going to clear this. So let's record the time you're going to be using here. So with this, we're going to execute this. And now here, we wait for 30 seconds. Since the cache is null, it is waiting and getting it from the data or the SQL database. The next call is going to get it. So 121 milliseconds. This took 3 seconds. And now execute again. Now you can see, until the 30 seconds elapses, it is still going to use the cache. Now let's click on it so the 30 seconds elapses for a new call to be done or to be made. And let's check it out. And that call must use 3 seconds and above. So let's see. Yeah, so you can see that we have it in here. Alright, so once you have this, we're going to, now you can see next call is very quick. Let's clear the cache here and I'll check it out. So I'm going to clear the cache. It seems you're not having this cache cleared in here, do we? Let's go through and have a look. Okay, we did not specify any header on top, so no HTTP verb. So this is, let's assume this is get, and then here we're going to say that this is clear cache. Okay, now let's restart this again. So let's see. All right, clear this. Now make a cache, clear this. So let's get the content again. Now the next subsequent request, you see we are having this working. Let's clear cache and see. Okay, I'm not getting it. Okay, so we are implementing that in the API 2. Yeah, so this is the service, and we are implementing this in here, and we are going to call this endpoint to clear the cache, right? So in order to do that, maybe we can try that in the client, but for now, let's try that in that's the server itself. Okay, so from here we have the API 1. We're going to introduce API 2. We have this the clear cache. So for the first start, right click on this. Let's go to inspect element. Let's click on this network tab, and now we're going to make a first call to this weather forecast, whereby it doesn't cache any. So it's going to get it 3 seconds, 0.2. Now execute the next one, 52 seconds, a millisecond. You see that is it. Now let's clear the cache here. Now check it out. So click on this and now clear cache. Nothing happened. And I'll make a call again, and I can see that it is now calling the same endpoint again, right? So get it. You see this working. Let's clear cache. Cleared, and now let's get the content again. And you can see it is still waiting. So that's a way to manage. So you can see this wrapper actually helps you to clear cache, set it to any time or anyhow that you want to be to do it. Okay, now let's consume it from the client. You know, the endpoint that you have in here, it is a clear cache. And so let's grab this. It's a get, and now that's a controller. So when you go to this weather controller in here, we can make a copy of this. And now we're going to say that this is clear. So weather forecast / clear cache. Okay. And now in here, we're going to say this is clear cache. And now, let's say clear cache. That is all that we need to do. Now this is going to return no content. Okay. So maybe it's still going to work. So return no content or return okay with the data, or return no content, anyone. It's still going to work. Let's see. Let's run this up and check it out. So this is also ready. Now let me clear this. You see we have this a cache. Let's get a call. So we're going to populate it now pending for 30 seconds, 60 seconds. Subsequent one are cached. Now let's clear the cache. So clear this. And now here we are having response of 500. So internal server error from this exception handler. Okay. So there's an issue here that we need to check it out. So what is an issue that we are getting? So let's check from here. Alright, so you can see when you check, it is returning no content. You know, this cache is returning no content. And here, so maybe let's return okay. And now since this is returning okay, we cannot, and it's returning just an I action result. So when you go to the controller in here, you can see I cannot return this. So this is get from. Let's use get async for this. And that is all. So return okay. Alright, so now let's run this. Check this out again. Okay, so it is ready now. Now from the caching, let's see. If I click on this execute, I'm going to get the new set of data again. So we are making another query, a new query. Now once you have it, it's going to be, that's been cached already. So subsequent once you have it. Now let's see from the clear cache, try this out, clear this, that's been called. And now let's see, as soon as I click on this, you're going to get a new one again. Yeah, so you can now clear the cache. You can also set the cache. You see? Yeah, so this wrapper actually helps you to manage the cache on your own. Good. All right, so that is one way of implementing the in-memory caching. There's another way that you can use system.runtime.caching. Then you can also use the package introduced in there already. You can also do that as well. But actually, there's also one. Then let's say distributed caching. So distributed caching in .NET Web API refers to a caching strategy where cache data is stored in a distributed cache system, which can be accessed by multiple instances of an application, often running on different servers. So distributed cache system often runs on its own. This approach is particularly useful in scenarios where an application is deployed across server farms or cloud environment, ensuring that all instances of the application can share the same cache data. So each doesn't have to cache its own data. No, all the data has been cached at one central place, and all of these instances can have access to that data at once. Okay. Now, what are the key benefits of using distributed caching? The scalability is reliable, it improves performance, and consistency. All the time the data is there, as soon as it is cached, and all instances can still have access to. There are a lot of providers who provide this distributed cache system. We can use an SQL server to handle that. You can also use Redis to also do that. You can use an Ncache, you can use Memcache, and even for trial purpose, there's also an memory distributed cache provided by Microsoft, and you can use that. It's already included in the system, so you can use that. But that one is not advisable to use that. It is also it is just used for testing purpose. Okay. But in this, I'm going to show you how to use this Redis to actually hold cache data and now serve it onto servers. You know, I said earlier that Redis is one of the cache provider. You know, Redis is an open source in-memory data structure store used as a database or cache and our message broker. It supports various data structures such as string, hash, list, set, sorted set, with range queries, and a lot. Okay, so in short, Redis is an in-memory data or data store which can hold our cache for us. And now this runs on its own server. So even when your web API is down, this server is still available and the cache still persists as far as the time or the expression time is not due. Alright, now how do you run Redis here? Before we do that, there are several ways to run this. You can use the WSL, that is a Windows subsystem for Linux. We can also use Docker. I hope you've heard of Docker before. Yeah, we can also use Docker. And the last one, we can also use Redis for Windows port. So in that, you're going to be using Docker since it is easy to use or easy to implement. So since Redis is going to run on its own server, we need to make this server available, right? So that's the reason why we're going to use the Docker to run this Redis. Now, just pick your browser and now go to just Google and type in download Docker desktop. So this is a site that's going to take you to, and now just Docker desktop, you can just install this app from this section. I have that already, so I need not to install this again. Then I'm going to launch this app. So you know, when you run it, you have to install the app, and now when you run the Docker desktop, you can see we have to check here, engine is running, right? So this is running, this is active. So this is what I'm going to be doing. What we're going to do here is we're going to install this my Redis image. Okay, so how do you install this? Let's open PowerShell. So window PowerShell. Then in that, we're going to start with that. So here, this is what we're going to do. First of all, to check if Docker is actually installed, yes, although you have the view, you can just type in docker-version, and you're going to see the Docker version that is 28.0.0, okay? And in that, we are not actually looking at this section. What we need to do is install this, our image, okay? So just type in docker run. It's going to download this and run it. Now you can specify a name to this if you want, and now this is my Redis. Give it any name at all that you want. And also we have the port. So default port is 63. Instead of P, see what I did? Yes, don't do that. Yeah. So 6379. That's the in, and we have the out as also 6379. I'm going to repeat the same port as well. Okay. So now that we have this, we have detached. It means you don't want to see the running session in the console. Do it at the background for us. We don't want to see that. All that you need to do here is you want to see this run. Then the image name is Redis. Make sure you type it correctly. And now when you're done, hit on the enter key. Alright, so unable to find this latest locally. Alright, so let's see how to go about this. Alright, so you can see that here it is downloading this, and now please you wait for it to get downloaded. Then we can now move on. So let's say it's almost done. You can see we have only one left. So this will just download it and I'll run it because we made a Docker run. Okay, so to see this, you can just type in Docker PS, and which will give you all the images which are running. Good. Now we have this. It is running 42 seconds, and there's a port. So we have our in, we have an out, 6379, and the name is my Redis. All right. So this is what we need, and this is a local host, isn't it? We have a port in here. Good. So while this our server, Redis server is running, you know, configuring is very simple. You see that? Yeah, very simple. It's amazing. Okay, so now we can now go back to our application. So let me put this on the second screen, although you cannot see, but as for me, I can see. It is not closed, it is live. Okay, so now that we have this set, what's the next thing to do? We are now going to install a package known as the Microsoft.extension.caching.stack exchange Redis. Okay, so let's install that package in here to our service. Right click on dependencies, and I go to manage NuGet packages, and in here, maybe what I'm going to do, I'm going to type in caching.stack exchange. Let's see if we're going to pop that one up. So stack exchange.redis. So we have Microsoft.extension.stack exchange Redis. Yes. So make sure you install this package as well. This we're going to be using to manage our Redis as well. So let's see. Accept this. Good. And I believe you've done the installation nicely, isn't it? Okay, so now let's go to our controller, and now we're going to implement this. We're going to use this distributed cache. Now this actually enables you to, or helps you to interact with the cache, no matter how, or no matter who the cache provider is. It could be the cache memory, it could be the Redis, it also could be the SQL, and it could be the Redis, yeah, as I mentioned earlier on. But it's still, the implementation is still the same. Okay, so let's see how to go about this. To use the interface, we first have to register this. So let's come to this side. So I'm going to comment the netcode package, okay, because we're going to use it. We are using a distributed session, so I don't want to. Let me close this. Yes, so we have this, and definitely we're going to be closing all this as well. Let me comment this one. Also this. Actually, this is only the one, so I'm going to comment this. Okay, we come back to this later on, don't worry. Let's save this. Now from the program, we're going to be adding, so builder.services.add. Then here we're going to be using stack exchange Redis. Have you seen that? And here we need to specify some options. This options allows us to specify the configuration, that is the port. So in that, let's see how to go about that. First thing is option.configuration. You can see we have it in here. So option.configuration, and at this configuration, you can specify the 127.0.0.1, right? Or you can specify localhost, and at the port here it is, what is the port? 6379, isn't it? 6379, and that is the link, the connection link in here, right? That's the address. Okay, aside from that, we need to also specify the option. So option dot, maybe you can use the instance name, and that is my Redis, my app, my Redis. So my app. Good. Let me remove this. So what matters most is this one. So that's the most important thing. So now that we have this set, good. Let's go to our controller. From this, our controller in here, and now let's use this. So in order to do that, we have to introduce distributed cache. Now let's say this distributed cache. So let's grab the instance in here. That's an interface, and at this interface we can now have access to it. So let's say we are going to cache this. What we're going to do here is we're going to have, let's say this is order data, is equal to await this dot. We have get string, so we can use that. So we have get string. So now with this get string, we need to specify a key, right, and a cancellation token. So maybe we can just grab the key and the token from this angle and now paste it on in here. Good. This is very simple. Now when it comes to this section, we are going to set it. So in order to set it, we're also going to do the same thing here. And now we're going to do, say that await then distributed cache dot set, set async. You can now specify value as in byte, and this can now set the value as what? String. So before you set the value as string, you need to serialize it as we did in the wrapper. So here too, we have to specify the key, the value, and the cancellation token. So what is the key in here? That is a weather data. And what is the value in here? That is JSON serializer dot serialize this one, the data here, and we need a cancellation token. So cancellation token dot none, we can specify that, and now we are good to go. You see this? That's all we need to do. You return data. Now for cache clearing, what can we do? It is the same thing. Await. So distributed cache dot, then remove async. Now let's pass in a token. So I'm going to copy this from here. Yes, I have a very simple one. Okay, when you copy and paste, it makes programming sweet. All right, now that we're almost done. We're going to run it. Now we make sure that our Redis is running. So when I check this, my engine is on it. Okay, I have a lot of fuel in it, so it is running. And also when you check the console from the Redis PowerShell, you see it is also running. It is in there. Now I'm going to run this from here, and now let's have a look. But before that, I think we're going to have an issue here because we haven't registered that. So let's remove this before it gives us an issue. Alright, so it is up and ready, up and running. Now let's see from in here we have our cache. Let's open our console so we can see the time being used. Now in here, let's open the weather forecast. We're going to make a first call. Now this is supposed to take 3 seconds. So it did not, it's used the cache because I've already clicked on it before. So let's wait for 30 seconds to get elapsed so that we can have a new one. So this is also still using this one from the server. Let's wait. Now keep on clicking on this, clicking on this, clicking on this. Okay. Now let's see if I click on this to clear the server. Let's see what happens. So I'm going to clear the Redis. It has been cleared. Now let's see from here. Let me just close this. And now start from here again. Click on this because now it is getting it from the Redis server. That's our cache. It took 3 minutes. No, 3 seconds, 12 milliseconds. Now from this one, you can see 156 milliseconds. And if I clear this again, it's cleared. Since I make another call, it's going to delay this. So it tells you that our Redis is working. So this, if I open a new instance from another browser, I can still get access to that when the time is not due. So let's try this. Let me open one instance from another browser. I have Chrome in here. So I have an instance in here. Now let me just get this cleared. So I'm going to clear this. Okay. Now let me make sure I copy this. I go to the Opera. Then let me just run this to get the interface in here. Okay. I have this. Now let me execute this. So execute. I have this in here. It's taking 3 seconds. Now subsequent request is going to take 19 milliseconds. Now let's open the Opera. And in here, I'm going to right click on this, inspect element. Then let's check from the network tab. Within that second, there's a network tab. Let's see if the 30 seconds hasn't. Click on execute. Now try this. Execute. And I can see that it's using what? Only 149 milliseconds. Now if I click on this again, it's using 144 milliseconds. Now let's wait for 30 seconds to get elapsed. Now let's see, is it going to make another new request to there. You can see now using 356 milliseconds. Try this out. Try this out. Try this out. So I find out that it does not automatically get removed. But if you click on this clear cache, as for that one, it will be removed. So let's see from the other app. If I clear cache from here, clear this cache, now open the Opera, and as soon as I make another call, let's see the time that's going to take. Make another call in here. It's going to delay for about 30 seconds, and I'll make that call. No, 3 seconds. The reason is when we check our source code, we did not specify any option. We did not specify time, and I believe you saw that, right? I did not see it earlier. I just saw it. Okay, so let's have, this is options. We can specify is equal to new. We can have this distributed cache entry option, and now within that we can specify it. Maybe this is what we have: absolute expiration and now sliding. So let's use this one, and this is equal to time span dot from seconds. We want to specify the same 30 seconds. So when this elapses, whether this cache is being used frequently or it is rarely used, it's going to get cleared off. Okay, so that's the reason why we're doing that. Okay, so now that you have this, we can now use this option in here from the set. Aside from this, let's see if I put comma in here. You can see we have option first, so let's put this option in here before that, and then trust me, there's no issue now. This is going to work 100%. Now let's wait and now check this out. Okay, so if I go for this one, you're going to make a request to this to record that time for my network. Try this out. Then it's taking our time, the normal time, 2.06. Subsequent one, 187 milliseconds. Now let's open this too. Now in here, clear this. Make another request in here saying it has been cached. It's going to take some milliseconds to get that, 65. Yes, but as soon as it gets up to 30 seconds, the cache gets cleared off from the server. Now let's wait and see. Check it out if you're going to have a new call for this. So even from the Opera to, let's see, from this, you want to get it, execute. Now you see it is now delaying for that 3 minutes, that's 3 seconds, right? Now when you go to our this side, execute, it has to get from the cache, and you can see quickly we got that. You see that it took just 77 milliseconds, and now that's an 80 milliseconds for that. Okay, now you can also clear the cache and now to make another call as well. So let's see from here to, it's not the 30 seconds elapses. Let's see if you're going to make another call to that. Yeah, you can see now it is making another call to this, and using that 3 seconds and 12 milliseconds. Good. So this is working. Okay, this is working. So that's a way to implement distributed cache and also the in-memory cache in here. Alright, so in a summary, we've seen that the in-memory cache here, it is used for a single server whereby data is cached in the server's memory for a subsequent response that comes in from the client. And now this improves the service response time, and also it sets the database free from processing or computing hard or tough queries. And also for distributed cache, it is used whereby you have to scale the application into more instances, whereby all of them are going to inherit from one server cache, and that is the Redis. And now we've seen how to run Redis in the Docker and how to connect it and implement your cache system in it. I hope you guys, you love this, isn't it? Yes, if you do so, then don't forget to subscribe if you haven't done so, and click on that notification bell to receive update as soon as I upload new content. Also like this video if you learned something meaningful or informative for you. I do offer coaching or mentoring sessions to people who are interested in improving their skills. So if you are, just check the email description. Check my description, I have an email they can write to me through it. Alright, catch you again. You have a last thing that I'm going to talk about, and that is creating robust and REST API. I have the last content for you. and I believe you love that as well. Okay, if you haven't checked the previous video out, check the video description. You have the link in there, and when I'm done everything, I also put it as one so you can watch it at your own pace. Take care, and see you again.